Hello, this week we're looking at decimals, and decimals are basically part numbers. This lesson or this video might be long, but I'm going to tell you where to stop exactly so that you don't have to listen to the whole thing all at once. Okay? So if decimals are part numbers, we have to think that very often in life, nothing, for example, measures up to a whole number. Like if you measure a room, very few things are like 4 meters. It's always 4 meters and a bit, and that bit, or those part numbers, are basically decimals. So when you were in grade 1 or 2, maybe like younger, you learned to count with a number line. And if you look at this number line, okay, it has, like here it is, and it has whole numbers. And this is basically the way you learn to count. For now, I want you to ignore this big circle, okay? So, so you learn to count with 0, then you learn to go to 1, then there's A, 3, B, and then 5. So very, very simple counting, right? So you should know that the value of A is 2, and then the value of B is 4. Okay? So far, I don't really think I told you anything that you don't know already. So we're just counting up by whole numbers, just like you did when you were in grade 1 or whatever. So what we're doing for decimals is we're looking at, we're zooming in because there are an infinite number of decimals between each one. So we're like zooming in between these whole numbers, and that's where decimal or part numbers lie. So I want you to think of decimals as part numbers, as zooming in between two whole numbers. So what we're going to do, and this is the purpose of the circle, we are going to zoom in between the numbers 4 and 5, and we're going to look for all the numbers that are in between. So 4 and 5, and then we're looking at all these infinite numbers that are in between. Okay, well, actually not all of them. So the first thing I'm going to do is I'm going to put in, this is like the, like the telescope where we're zooming right in. And I'm going to say that this is the number 4 and that this is the number 5. Okay, so I'm going to do an arrow. Okay, so, do I have an arrow here? Well, I think I do, but I'm not going to use it. That's fine. I'll just draw an arrow. So here, now please excuse me if it's like a very crooked line. So here's 4, and then here is 5. Okay, so this number line is, like this number line here is expanded, and again, it's just this little part here. Okay, so all decimals are the part numbers that are in between. So we are going to count up by tenths. Okay, and so this number here would be 4.1. Okay, this number here would be 4.2. This number here would be 4.3. So we're counting up by tenths. Okay, this number here would be 4.4. Okay, this number here would be 4.5. Okay, now 4.5 is the midway point between 4 and 5, right? When we're counting up by tenths. This number here would be 4.6. This number here would be 4.7. This number here would be 4.8. And finally, 4.9. So all we've done is we counted up by tenths. Okay. Now we're going to move on, and we'll review this at the end. And we're going to see where do part numbers exist, right? So like I said at the beginning, when you're measuring like a room, nothing is exactly the right measurement. It's always 6 and a bit and 12 and a bit. So if we think about meters and centimeters, I would say that 6.7 is 6 meters. And how many centimeters? If you said 7, I don't blame you, but we have to remember that after this number, you can always add a 0. Okay, you can add many zeros after a decimal number, but when you're measuring, this is really supposed to be 70, so it'd be like 70 centimeters. Okay, so the next one, okay, would be 12 meters. And after the decimal again, you can always put a 0, and then it would be 80 centimeters. Okay, so it's 12 meters, 12 whole meters, and then it's approaching 13, 13 meters. Okay, the final one. Now it's a large number, but it's just a lot of meters. Now obviously this can't be our room because it's very large. So it would be 164 meters. And how many centimeters? Well, again, there's always a 0. Okay, so then it would be 30 centimeters. Okay, so measurement is a practical example of decimals. Okay, so if I move on, okay, here's addition. Now, for addition, what we always have to remember is that the decimals are lined up. Okay, decimals are always lined up. So I would just add like you did when you were younger. But so adding decimals, that's really the only thing you need to remember, right? So then 9, and then here's my decimal. Okay, I'll make it a little bit larger so you can see. And then that it's 11. So if I were to add 8.4 plus 3.5, okay, the 0 is just always added, then the sum is 11.9. And you could say 11.90. By the way, whenever you name a decimal, the numbers after are always said in single, right? 11.90. You don't say 90. Okay, so let's try this one. This is where probably addition might, well, this is the hardest thing I could possibly do with it. Again, I would just rewrite it, because remember what I said that, when we started, is that the decimals have to line up. So I would take 12.6, okay, and I would line up the decimal right underneath, right? And that's why, and here you see why it's so important to line up the decimal, because you want to add tenths, right? So this is tenths here. Okay, you want to add tenths. If you write it like this, right, and I guarantee somebody will, the decimals are not lined up, and then what you end up doing is this is a tenth and this is a hundredth. You're adding a tenth and a hundredth, so this is a big no-no. Okay, so once you line up the decimal, which in my opinion is the hardest part, and then I could even put a big decimal here, so that's the sum. Then you just add like you always did. So I would say that this is a 1, that's 10, here's 6, and 1. So the sum is 16.01, right? Okay, so if you are, we're going to review the video, and we're going to multiplications for next time. Okay, so actually you reached the end of the lesson, but let's just review what we talked about. So we talked about how decimals are like numbers that are in between whole numbers. So here's a whole number, okay, and then the decimal numbers are in between. Like we have to zoom in. You have to zoom in to see them. So then we put the 4 here, we put the 5 here, and then we count it up by tenths. Okay, and so that's what we did first. So this is a good way to represent decimals. And then if I keep going, we talked about how almost all the time in life, like nothing measures up exactly to a whole number. Like even if you measure your height, nobody is exactly 1 meter. Nobody's exactly 2 meters. If you remember in class, we put 2 meter sticks together. Most people are somewhere in between 1 and 2 meters. So it's like a decimal, right? So if I were to say, how long is something in meters, I would say that in meters it is 6 meters and 70 centimeters. Okay. Or if I were to say something is like 12 meters, it'd be like 12 meters and 80 centimeters, right? Or I know it's large, but 164 meters, which is quite long, and 30 centimeters, okay? Finally, we did addition. Now, the most important thing that we need to remember for addition is that the only way to really, well, make a mistake is if you don't line up your decimals. Rewrite it. So if it's written like this, rewrite it so that your decimals are lined up. And the reason why we do that is because we want to add tenths and tenths. Okay, we don't want to do this where the tenth is here and a tenth is here. Right now, finally, that's where we stopped the first video. But now the last thing we're going to do is multiplication. But multiplication is sort of like the next day. So I will multiply these two. Now, multiplying decimals is not very hard. It's actually probably, no, I wouldn't say it's easier than addition. But anyway, what I'm going to do to multiply, I'm going to ignore the decimal. So I'm just going to write it like this, right? Okay. So I'm multiplying really 67 and 81, but I'm not forgetting about the decimal. I'm just sort of putting it aside for now. And then what I'm going to do is I'm going to multiply here, just like we did before. Okay, times 1 is 6. Oops. Let's try that again. Okay. And then 7 times 1 is 7. There we go. Okay, so I'm multiplied. Now I'm ready to add my diagonals. So this is a 7. This is a 12. I carry the 1. This is 14. Carry the 1 again. Okay, and I'm circling the 1 when I carry it. It kind of helps, right? Now, it's possible for everybody to make a mistake, so I'm just going to double check it. There we go. Now, the only problem is, as I said that, okay, I'm putting the decimal aside, and now I'm putting it, I have to put it back. You can't just say, well, that's the answer, because it's not. So now I'm going to reintroduce the decimal. So what you do is you look at how many decimal places there are. So there's one decimal place here, and there's one decimal place here. So if there's one decimal place in each, that means in total there's 2. So there's 2 decimal places. It's right here. So you count from this side. Okay, 2 decimal places. So if you were to multiply, that's the wrong symbol. If you were to multiply 6.7 times 8.1, the product is 54.27. And then I could even check that on the calculator too. So I could say that 6.7 times 8.1. And there we go. Okay, and that makes sense because we also know that, and if you think of estimation, 8 times 6 is 48, right? So the product for this, like 54, well, it's close to 48 because there's additional little numbers here. Okay, so that's how you multiply decimals, and